Okay, welcome to today's session. Appreciate you all coming. It's always kind of a little bit of struggle to be the last one in the afternoon before a fun poster session coming up right afterwards. We really appreciate you coming and joining us for this. So real quickly, my name is Dave Meyer. I'm the manager at the Goddard Earth Sciences Data and Information Services Center. And yes, Zong, we got to change that name sometime. It's a mouthful. Okay, I've been interested in analytics data for a long time. Our data center, GESDIS, has been involved with all the other data centers at NASA in the process of migrating to the cloud. And one of the big issues that kind of comes up is that we've been dealing with these data formats and things like that haven't always been as application friendly as they could be. Well, over the years, there's been an increased interest in just let's simplify things. Okay, I don't just want to deal with NetCDF, HDF5. Personally, I don't have an issue with it, but there's a lot of people who are trying to come in and consume these things in like GIS platforms, and things along those lines. And, they don't really want to mess around with a lot of data. They want things ready to analyze, okay? And so we're going to be talking about that really quickly. The problem with analytics data, and this has been analytics ready data, analysis ready data, is that it's difficult to come up with a specification that covers everything. And the reason for that, and we have a number of folks who are going to talk about that here, it's like application ready. What's your application? Okay, some folks, you might be interested in just looking things in sort of a map-like, configuration, maybe drill down through time, for example. Okay, some folks may be just more interested in things that are more organized a long time, all right? And so when you're trying to come up with a specification for that, the broader you get, the tougher it becomes to actually, implement something that's specific to a community. You could end up with the least common denominator solution, and the more tight you get, the more you tend to exclude people, who you might need to be involved. And so we have a group of folks here that are going to be talking about that, but I'm going to step through some real quick concepts here early on that, things that come out of, this fertile brain here. Okay, there we go. Okay, so, you guys have probably already seen this. You can go out to the CIOS website, and say, what is analytics data? This is the answer, okay? So it's been processed to a minimum set of requirements and organized to a form that allows for immediate analysis with minimum additional user effort and interoperability, through space and time, with other data sets, okay? I'm gonna try to compare two things and they're not aligned in the same grid, for example. Or let's get really messy and let's say I want to look at swath data, like level 2 data in the NASA nomenclature. How do you bring that in? Is it even possible to make that analytics ready? Well, we have some folks that are going to be able to talk about this. So here you can see the basic concept. It's just something the USGS has been involved with this for quite some time. Specific to Landsat data. Landsat data, as many of you guys know, are organized around this path row scheme. They're organized around seams. And you have to do a lot of messing around with them to make sure you can join them together, spatially, drop through them in time, because they're not, the satellite doesn't image in a way, that prevents that to do easily, right out of the gate. An early activity here is something I think you guys are all familiar with, the CIOS analysis ready data for land, CARD for DL. Okay, and you can see, this is some of the stuff straight from the CIOS website. Once again, repeats more or less what the definition of analytics ready data is from the CIOS perspective, and points out that, if you're a producer, you'll have increased uptake, you'll have more impact, because more people can use it. You'll get more, movement throughout the community. Resource efficiency. Once you put this together, people are going to be able to consume it more or less in place. And then it does enable interoperability, because you're trying to align things that have different, say, satellite imaging morphologies, for example, and trying to align them to some common framework. For users, of course, it's going to save you time and effort, spelled in a very interesting way. And so, you always hear this, that's sort of the 80-20 rule, right? And this is something I've been hearing for, probably 25 years, right? I spend 80% of my time messing around with trying to get data ready, and 20% of my time actually analyzing it. I don't know how those numbers exactly stack up, but that's been a persistent problem for a very long period of time. You capitalize on the experts, okay? You have the people, I as an end user may not care about, just exactly how, MODIS is organized in his raw state. I just care about, like, say, surface temperature, for example. Or if I'm a synthetic aperture radar user, if it's a complex valued number, what? I don't know what to do with that. So having somebody that's able to reduce these things in easily digestible terms, in common grids, along harmonized temporal intervals is very happy. And it makes a lot of people very happy. And so, you minimize your costs because you spend more of your time actually analyzing data and less of your time manipulating it, and then of course that provides for consistency along the data sets. Okay. All right, so here is one of the, I'm going to just call it one of the more mature ARD collections. Like I said, USGS is doing this for a very long time. This is a graphic showing how they've gone from, I guess they're on their second iteration, their second version of their Landsat ARD data sets. On the upper left-hand side, you're seeing just sort of like how they have increased, the number of, I guess I would say, the depth of their data cubes from their earlier collections to their current collections, so darker is where they've done a lot of additions. So you can see it's evolving over time. Then on the right, you can see that they've also developed a tool where if you want to take the Landsat scenes in their path row, the WRS orientation, and put them into a gridded format, they have a tool to do that, and the link is right there. And the citation, with my good friend, John Dwyer is a primary author on that. Okay. If you're talking about already gridded data, so I'm going to kind of just jump into some stuff, and Pei Xing is going to go into this in more detail. All right, it's great if you have gridded data, but when you start talking to a lot of the core scientists, they don't really want to mess around with a lot of data too, but there's problems with using these level 2 swath data. Can that even be made analytics ready? All right. So what I'm going to do right now, I'm taking this slides from something that Chris Linus had presented, I think maybe 3 years ago here. Okay, but just reiterating this right now that analytics ready data doesn't necessarily need to be limited to pre-gridded data. Okay, we also want to consider how you might do this to the more raw, purer forms of data as well. All right, so here's an example he talks about. So on the left, he's looking at AIRS data, surface air temperature. This is on the left, you see a gridded data set. On the right, you see the raw data set. And so it's really easy to see that when you grid things, you make some compromises, right? You throw away data in essence. You lose spatial resolution, because you're not dealing with the native resolution of the sensor anymore, and also you have a tendency to suppress, extreme values. Okay, so that affects, not only the resolution of the data, but also the actual range of the data, the anomalous data values that you might be the most interested in. Okay, so it would be nice if you knew how to work on that as well. And so he kind of just shows this example, like, I think this is like the surface air temperature. I believe this is MODIS. Oh, I'm sorry, no, this I believe is AIRS and this is MODIS, and he just kind of shows like, how you might, oops, I'm missing a slide here. Apologies for that. So in essence, you have two different data sets, in their raw parameter retrieved form, surface temperature. One is going to be a kilometer-ish data set that goes on a certain, that images in a certain morphology, I guess. Okay, and then but then you want to compare it with a different instrument. This is something that happens a lot, right? So I'm retrieving the same parameter from different sensors. I just want to see if they're the same. Or for example, if I'm producing a model output, like if you guys are familiar with the GEOS 5 model that NASA runs, they will put things out in a sort of a level 4 gridded format, but you want to go back and see if the data that you're retrieving, some of it which is going to be the same as that which is directly measured from the satellite, is faithfully mapped through, through the modeling process. And so, so I kind of dropped a slide out of here. I apologize for that. Let me see if I put it further in here. Nope. Sorry about that. So the missing slide, I'll draw a picture with my hands. So what he's kind of looking at is that he's saying if you follow one of these, say, AIRS pixels, so errors acquisition at time 1, time 2, time 3, time 4, going through the actual observation time steps, they kind of map all over the place, So, he's talking about ways of maybe going in there and trying to at least have a mechanism by which you can retrieve them in a way that, that makes sense, okay, that I can decide for myself, I want to make 2 different observations from 2 different times align with each other, okay? I might have my favorite way of interpolating and things like that. He may not agree with it, okay? So, so as we talk about analytics rated data, it's nice to pay attention to that community as well. Okay, so I'm going to jump ahead to a few things here real quick. We have Alexia in the room, so I did this, partly for you, since you're one of the, the water bearers for this activity, right? And so when you see the VITA is this visualization, again, help me please. Exploration. Okay, that was the E part. Yeah, so education, no, okay. Visualization and analysis, okay. And so what that is it's trying to say, all right, I want to take into account, how to visualize data, but I also want to look at having an analytics framework, but I also want to be able to present things in a geographic format. So, there's a lot of different data types floating around there. If you want to do the analysis, you want to do it in the rawest possible form, the least manipulated form. But if you're going to present it in sort of a map presentation, like in a story map or something like that, you need some way of mapping between these things, okay? And so you're going to have some reference, that maps through them. So this is an activity that would benefit, from a more harmonized approach to deal with both level 2 and graded data 3 and 4. In a manner that allows for rapid analysis with minimal messing around with the data up front. One of the things I do want to pay attention to a little bit here too, and I think it's overlooked sometimes, is in the process of doing this, as we sort of move through, the raw data into the retrieve parameters in native resolutions of the instrument, into level 3 and level 4 and things like that, you have to think about citing going forward, and you also have to think about the provenance, coming back. So as we generate these analytics ready data set, not only do we need to understand what they are, we now need to understand how they came into existence. Okay, so we need to have some kind of trail of breadcrumbs that takes us back, through the data, and hopefully the processes used, to arrive at these. So I'm just kind of putting this up here just as something that, we hope we pay attention to. All right, for our speakers. We have Matt Stevenson, I guess with the CIOS group. He is going to be joining us remotely, I guess, and I guess we're going to have some help making that happen. Josh Lieberman, he's right here. He's going to be talking about the OGC standards, for this. Zong Liu is here in the room, and he'll be doing this too. And I think we missed Pei Xing. Is Pei Xing here? So Pei Xing is going to be talking about the level 2 stuff, which, sorry I left you out because that's the stuff I care the most about. Okay, so okay, and then Dr. Li Ping Di, who sits on some of the CIOS standards committees and things like that, will be closing this up remotely. So I think at that, do you want to just dive into the presentation for Matt? I'm not quite sure how that happens.
Probably do the Josh first because
do Josh first?
Yeah.
Okay, I guess you're going to be next.
I don't see him right now.
Oh, is he? Is he on? Okay.
Cool.
Right.
Okay. Can you check it with him? Do you want to? Does he want to drive from his computer or?
I mean, I can do this from here if he doesn't mind.
Yeah.
It might be less complicated.
Let me show that slides.
Okay. Matt, are you on, and can you hear us?
Hi. Yep, I can hear you. Thanks for rapid response to the link.
Okay, so if it's okay, I'm going to drive for you. Do you mind? And you can just go ahead and start whenever you like.
Absolutely, that's great. Thank you. Yeah, sorry for the confusion. I only received the link a couple of hours ago, which was 3 a.m. for me. So anyway, only 5 minutes late. Let's get into it. So thank you for inviting me. I've been asked to present today on behalf of the CIOS Analysis Ready Data Group. there are two groups in CEOS that I represent as the Secretariat. It's the CEOS ARD Oversight Group and the Land Surface Imaging Virtual Constellation. Next slide.
There you go.
Thanks. So essentially, CEOS is a collaboration of civil space agencies around the world. We have 34 members now and 29 associate members, totaling 63 agencies operating 201 or so satellites as of the last time this was updated. It's a voluntary best efforts organization, and it's through this framework that we came together and decided to come up with a definition for analysis-ready data. CEOS.org, you can find more information there. Next slide. So back in 2016 or so, we saw this phrase, analysis-ready data for satellite Earth observation floating around. And that phrase or term is inherently ambiguous. It's really up to the user to decide what is analysis-ready. So it was causing a bit of confusion, and our land surface imaging virtual constellation was reformed at that time, with one of the headline priorities being to provide one such definition for analysis ready. Next slide. And there were three co-leads at the time. We had Geoscience Australia, USGS, and the European Space Agency. And they led a group of, I think it must have been 10, 15 agencies at the time to come up with this definition. One of the great drivers was big data platforms such as the Open Data Cube, the Digital Earth Australia, and now the Digital Earth Africa program have really been championing the use of analysis-ready data in massive time series collections and their application. So that was one such point that provided an application side driver for us. We felt that CEOS space agencies are probably quite well placed to define analysis-ready data for Earth observation. We really capitalized on space agency experience and scientists that we had access to. They came together to decide what do most non-expert users want. And so the definition we landed on was sensor agnostic geophysical variables. And so we set out to define key parameters and corrections for different types of geophysical products. And the concept is really built around ensuring documentation of what's been done in the processing steps for a product, rather than prescribing a specific method. So it's left open to the data provider to decide how they want to achieve the analysis ready. Just make sure that it's captured in the metadata and so on. Next slide.
Sorry. No, it's slow. Just give it a sec here.
Yep, all good.
Got it? You're saying, I'm not sure what. Am I seeing something different than him? Yeah. Sorry. I think something.
Let me.
Is this your slide, Matt? You get it?
Yep, that's the next one. Okay, so as I said, the motivation was this wave of big data that was approaching at the time, and it's only becoming greater. We wanted to reduce the pre-processing burden for users, so facilitate analysis in the cloud and reduce egress and processing. We also wanted to provide a first step for interoperability. And key is first step. We're now in CEOS coming up with an interoperability framework to identify some of the other bits and pieces that are needed, but we see ARD as a great starting point. Idea was to increase the pie of users as well, increase data uptake and foster new communities, and as I said, capitalize on space agency experience to help us get there. Next slide. So this is the definition that we came up with. CEOS analysis of data. Satellite data have been processed to a minimum set of requirements and organized into a form that allows for immediate analysis with a minimum additional user effort and interoperability both through time and with other data sets. So it allows interoperability, but does not fully achieve it, of course. Next. So the concept is built around these product family specifications. So we have a specification for each geophysical measurement, and they detail threshold and target or goal requirements for a variety of parameters. So we have 4 main sections: general metadata, Perpixel metadata, radiometric and geometric corrections. We have threshold, which is basically the minimum you need to achieve to be considered CEOS ARD. And there's also target and goal, which are honestly aspirational goals. We don't have any products at the target level and don't really anticipate them anytime soon. But those are there to help us chart future development and sort of a roadmap for where we'd like to get to. Next slide. So these are our current specifications. As I said, we started with the land domain, the land surface imaging virtual constellation. So we had surface reflectance, surface temperature, and normalized radar backscatter. We've added a few extras since. We have a nighttime lights product, a polarimetric radar product, and next slide. And once more.
Oh, there we go.
Once more as well, I think.
Yeah.
There we go. Sorry, getting fancy. Great. So yeah, we have a couple more in the pipeline. We have LiDAR terrain and canopy top heights, geocoded single look complex, and interferometric radar. The radar products are currently being harmonized into a single document. So we'll condense those down very shortly. The aquatic reflectance and ocean radar backscatter on the right, they are specific to those domains. They're basically derived from their land counterparts. So surface reflectance to aquatic reflectance and normalized radar backscatter to ocean radar backscatter. We published the specifications on our website, ceos.org/ARD, and you can find them in the table there. The SAR specifications also have an accompanying metadata specification, which provides a suggested way for laying out the metadata files, which makes the assessments quite a lot easier as well. Next slide. In 2020, that whole period's kind of a blur for me, or it was 2021, in CEOS, we extended beyond the land domain. We made a conscious effort to bring in our other virtual constellations for other domains, like the atmospheric domain, oceans domain, and set up a group called the CEOS ARD Oversight Group. And we're now thinking about what other types of geophysical variables might be useful for the user community. Things like sea surface temperature or ocean color. We already have the aquatic reflectance, but we're talking about extending that to cover the oceans. They're currently focused on coastal and inland waters. So yeah, it's an active discussion about where we go next, what geophysical variables. User demand is key, and it's up to the virtual constellations to decide that for us, and also to define the specification. So we're not trying to force it, but we are exploring it with our virtual constellations. Next slide. So this is how an assessment works. We have the specifications, which also double as the self-assessment table. So a data provider will fill out those tables, providing justification for each parameter, and also provide a sample product and sample metadata through to myself. I'll perform some initial checks, and then it will be passed on to our working group on calibration validation for a peer review. For the threshold level, we've kind of streamlined the assessments. It's just 1 or 2 people that take a look and providing feedback and work with the data provider to ensure that, there's compliance. If there was a case where we were working towards the target level, and as I said, it's not something we expect at this point in time, but for a target level assessment, we would convene a peer review panel to work through that in a more formal process. The framework is on the website as well, ceos.org/ARD. Next slide. So through our engagement with people at various fora, we found that the question we're asking is, would the commercial sector be interested in taking on this concept and implementing it? And basically the feedback we got was that, well, specifications are good and they capture a lot of good concepts and useful concepts. Formal standardization is really needed before they can commit resources to developing CEOS ARD as a standard product. And so we started bouncing around that idea, and we discussed with IEEE and OGC and ISO about entering a standardization process for CEOS ARD. It was something that seemed to have popped up in parallel in OGC and ISO. So it was quite good timing that we were able to connect. Long story short, CEOS is now involved in the OGC ISO ARD standards working group. We are serving through Patrick Quinn of NASA as co-chair for that group. And it's just kicked off, so we don't have a whole lot to report at the moment, but the idea is to build standards or ISO technical specifications at this point in time on ARD, using CEOS ARD as the basis. So if anybody'd like to be involved in that, please let me know, and we can send your email to the appropriate places to get you involved. Next slide. So as I said, it's only just kicked off, so we don't have a whole lot to report in terms of the actual standard development, but the group was approved on the OGC side in early May, and later in May, the ISO counterpart. I think the idea is to generalize the ARD standard from satellite Earth observation to geospatial data. There's a planned 2-year development period. And so it is it's marked to be called ISO 19176. And the first part is the overall framework. Next slide, please. So these are our current CEOS ARD products. There's just a table from ceos.org/ARD. On the next slide as well, there's details of upcoming products that CEOS agencies are working towards. There's quite a few of them in the pipeline, so I won't put the whole table here because it's pointless, it's too small to read once it's on there. But yeah, I encourage you to take a look on the website and let us know if maybe you are working towards any of these assessments. We can add you to the website as well. Next slide. Just a quick slide on applications. Actually, I already covered it. So one of our key drivers was the Digital Earth platforms, Digital Earth Australia and Digital Earth Africa. Digital Earth Africa showing off some great applications. We've captured those in a few case studies. It's kind of, you kind of realize how big Africa is once you start seeing how much data they're dealing with. And it's quite an impressive project. So I'd encourage you to take a look at Digital Earth Africa. It's a key user of our CEOS ARD. There's just another case study in the top right from CSIRO about using our Sentinel-2, and comparing that to a NovaSAR, CEOS ARD normalized radar backscatter product for burn area mapping. Some contact details on the slide if you're interested. Next slide. As I said, we've been engaging quite broadly. We have a large team on the CL side, and so we'll split our representation at various meetings. We attended the ARD 23 workshop, which was a week-long industry-led CEOS ARD, sorry, not CEOS ARD, ARD and interoperability focused event. That was really great. And so we presented there and had a session. We're at IGARS this week. So there's various people floating around, and VH Rotor and JC and ESA Living Planet Symposium have been key events. And so we'll continue to be represented and spreading the word. As I said, we've got CEOS ARD webpage, ceos.org/ARD. It's got all of our information there. And yeah, next slide. We also have our Twitter. I'd encourage you to follow twitter.com/CEOSARD. Maybe Twitter is not the flavor of the month anymore, but maybe we'll have to look at some other platforms actually. We have a CEOS ARD newsletter, which you can check out. It's ceos.org/CEOS ARD newsletter. There's a few past editions that we've put out, and also should be a link to sign up for the future ones. The best point of contact, I suppose, would be myself, since I'm the secretariat for both the LSIVC and CEOS ARD oversight group. For the oversight group, Ferran Gascon of ESA is our lead, and LSIVC we have Andreas Kjær from Geoscience Australia, USGS Steve Levan, and European Commission Peter Strobel. So their contact details are on the respective pages on the CEOS website. So feel free to reach out to any of us at any time, and happy to engage. Next slide. That's it. Thanks a lot.
Thank you, Matt. So we have time for a few questions for Matt. Any questions? So I can't see the chat if there's anything coming in there. Okay. Okay. No questions? Okay. Thanks, Matt. Appreciate it.
No worries. Thanks a lot.
Oops, the wrong one.
So I can just make sure that
I think it's good.
Okay, good.
yeah, just the share got interrupted. So we're gonna share that screen.
All right. Thanks. So this should be interesting because we didn't really coordinate these presentations, and we're all kind of working on the same set of committees and the same issues. So, but hopefully we'll have a different emphasis in each of these presentations. So I'm going to talk about standardization of geospatial analysis ready data, and Matt already pointed out that we're looking at this more broadly in moving from the CEOS ARD work to the OGC and ISO work, but there are also a couple of other changes in emphasis. So we're changing from, as you said, the production of satellite data to the applications and really the user perspective, and asking what is readiness from a user perspective, and also looking at it from the ground up in some ways instead of space down. One of the somewhat controversial aspects of this is to say that literally satellite observations are not ground truth. They're a signal, but if you're trying to study the Earth, then that's a process, many processes. And in particular, it involves other data. And so a large part of asking about analysis readiness is asking about integration readiness and what better characterization of the Earth and features on the Earth can be achieved by these states of processing that the analysis-ready specs talk about. So we're going to try hitting this, and it's not going to work. So let's try that. There we go. All you had to do was stand up, so just keep doing that. And we'll go back. I hated this. Control. There we go. Nope. Totally the wrong one.
Went a few too many at once, I think.
Yeah, about 5 too many. Yeah.
Yeah.
Okay, now it's
All right,
working.
cool.
It's not up and down. Okay, so quickly, many of you know about the Open Geospatial Consortium, but for those that are not entirely familiar, it is an international standards organization, an international consortium of agencies, nonprofits, and industry organizations interested in the better sharing of geospatial data. But that's only part of it. A large part of it is innovation, is initiatives and activities that say, where in solving problems of data sharing is there a role for a standard? And having a standard, how is the best way to make use of that? And how can we encourage adoption of that by showing the standard involvement in solutions and improving the sharing of data. So there we go. So every one of us has to talk about what is analysis-ready data, and the CIOS definition is particular to satellites, but it's very cogent. It says, these are specific measures to take. There are other definitions of that have been developed. There's a perspective of, really documenting the collection, showing that it's been responsibly done and reviewed, clear, consistent, and error-free results to the greatest extent possible. So that's a very general, broad definition of applicable to any data. And one from Planet is sort of very concrete. It's like ARD is a way to make deep stacks of data so that you already have the stack. You can stack it with other things. You can connect it together. So that focuses on the ability to move right into tools for analysis and visualization and combine with other sorts of data. The value of that is becoming clearer and clearer. 15 years ago, we tried to build the system for a very large satellite data provider of these stacks of tiles that are all consistently matched, and you can go through and say, I want this, this, and this one, and the ability to vend and discover and order imagery that way was terrific until somebody discovered that 5 to 10% of the pixels lying outside of those tiles wouldn't get sold, and then he canceled the project. So it's a matter of priorities here. It's not the best way, but it's the best compromise for end users and applications that we can get to. So you saw the CIOS view, and I'll just pick a couple of these things out because they're what we're looking at in terms of this framework. And Matt mentioned that the first specification part is really to do this general framework out of the work so far done by CIOS. And it has 4 pieces. Probably, at least according to many people, the most important part of the first 2 is document, is the metadata for the data sets and the metadata for every pixel so that you can decide whether that pixel is ready for analysis. The next 2 are also important, particularly for the kind of making data GIS ready, but that's very variable according to what the application is. requirements for radiometric corrections and accuracy, and requirements for geometric corrections. And in fact, those are pretty highly correlated if you have the ground view, because if you don't know what ground you're looking at, then how it's radiating is of less value. So here are some exemplar use cases, and these come from work we're doing in one of these innovation activities, Testbed 19. So analytical reuse, I have this process and I want to use it for data from different times or different areas, and I don't want to have to keep redoing the processing every time. I want the data to be ready to shorten that workflow. But as other cases have been discussed, longitudinal interoperability, to be able to compare the radiometric values over time, particularly, those ground values, bottom of atmosphere and Earth surface properties. It's one thing, as it's been pointed out to me many times, to say, well, I'm going to use Sentinel-2 and I'm going to look over time. It's another to say, well, there are these cloudy pixels, there are other things. I want to combine 4 different sensors and look at my longitudinal interoperability. So different levels of challenge, but a similar application focus. And then analytical aggregation, being able from the spatial alignment, but also the definition and comparability of the variables to be able to integrate different sorts of data together and to provide the sort of ground information, but also different elements of models to work together. So as Matt did discuss, there's a standardization challenge and opportunity. Since CIOS is not a standardization organization, developing standards in OGC is a means to mandate and put into procurement and other arrangements the conformance to that standard. And in particular, that's an essential element of OGC standards, is some form of defining and testing conformance. There's an additional value for ISO standards because the arrangements for that mandating standards are more automatic. So while various governmental bodies have decided to mandate this or that OGC standard, it's a much more automated process for ISO standards. So the reason to bother with the difficulty, to be honest, of developing and passing and adopting ISO standards. So also another part of this is this idea of a broader community, a broader applicability, and particular interoperability between EO and non-EO data. So these are reasons that it's valuable for all concerned to move to a standardization process with innovation inputs through OGC. So the standardization process, you're probably familiar with already. We start with CIOS ARD specs as the base, build on existing OGC and ISO standards, and work at a broad community consensus that when these standards are adopted, and when, in the case of OGC, there are conformance tests that can be applied to target products, that there is a broad community ready to adopt and make use of those standards and realize their value. Just quickly, the structure of an OGC standard, they're adopted, implemented, testable specifications, reusable agreements. They're set up as a set of requirements classes that are then paired with conformance classes. So this is the conformance with the standard, and this is how you demonstrate and test and assure that conformance. So part of adopting and publishing the standard is to have conformance tests as well. And there are different levels, of course. You could say, okay, this general product family, you could say this particular platform and organization. You could also say, I want to know that every image is also conformant, particularly if quality standards are involved. So there's a lot of actually innovation work that's needed on this issue of conformance. So the OGC standards are generally modular. They try to make pieces that allow flexibility in conformance. You can conform to just a core or to any arrangement or number of extension modules. So that gives an opportunity, for example, for different product families, a la the CIAS ARD specifications, but also allows, for example, conformance to different quality levels or different classes of analysis for which the data should be ready. So this is in the charter of the standards working group, which is the OGC body that will develop the specification. And part of that is coordination with the corresponding ISO working group, ICTC 211 19176 working group. So shared members is a part of that. There are more details which I don't have a couple of hours to go into that we already spent a good part of this morning talking about, but there are issues to work through, part of the mechanics of standardization. But the standard will be a multi-part standard, a modular standard. There's a possible roadmap, but that is not yet set in stone, so the SWIG needs to determine its path as well as how to follow it. The ISO ARD roadmap, I'll just throw this up because I think Li Ping's going to talk more about this, making use of the ISO facilities and procedure, different ways of getting on each of the committees, so each of the working groups, so that's going to have to be worked out, which is in process. So that's the standardization work, but I want to turn very briefly to some of the innovation work that's been around analysis-ready data. And this is just a bit of a show of the innovation program, which has these different technology readiness level activities. The earlier ones tend to be, what's the case for what would a standard look like? The later ones, such as pilots and operational exercises, are, we have a standard, what are the implementation and adoption issues? Yeah, too many. I have to get rid of that. Okay, so this actually started this research and development in TextBed 16, looking at the CIAS definitions and looking at issues of generalizing the concept, and particularly in applying it to the domain models and other artifacts of the OGC standards baseline. It particularly looked at the issues of analysis readiness in terms of encoding and transmitting data, and particularly this is the beginning of looking at the code to the data, of keeping code in a processing ready format so that code could be brought to it and minimize the movement of data during the analysis process. And then testbed 19, we've returned to this to look at a number of aspects of, what are the parameters and limits of analysis readiness? What are different types of analysis readiness that can be considered? How does it connect to reproducible workflow? How does it connect to interface issues such as with Geodata Cubes? So these are two tasks, analysis ready data and Geodata Cubes, occurring in testbed 19 that can be followed along for anyone who's interested in observing the interesting discussions which are occurring there. So, and this is the Geodata Cube. The idea behind the Geodata Cube is a structure which is able to give a uniform view and uniform way of processing, of accessing and subsetting a variety of data. Some of it is coverages, imagery, some of it is not. But that has a great affinity to the kind of cube stacks that analysis-ready data is well suited to be shown as. So that connection is made very real in this testbed activity. So one last thing is on the application front, what is analysis-ready data good for? And some of the applications that we're looking at, for example, in the disaster pilot series that OGC has been carrying on, is how do we provide awareness, both shared and specific awareness, the right information to the right person at the right time, and from the sky to the ground. And that requires the timely and scalable processing of data to be ready to influence and guide decisions. An important part of that is to be able to start with analysis-ready data, because you don't know when or where the disaster is going to require data. And so the more consistency there is, the more interoperability of, I have the same process and I can perform it for data here at this time or there at that time. So it plays a very important role, particularly puts particular constraints and requirements on what is analysis ready in this particular case. So it's just one of a class, one class of many applications of analysis ready data, but one that we're trying to develop cogent requirements from. And I think that's it. Thank you.
Questions for Dr. Lieberman?
Thanks, Josh. I know in a discussion about standards, trying to stay go beyond just satellite observations or like Earth observations. And when you're discussing about the ARD testbed 19, I see quite a few sentences specifically mention about Perpixel and other things. So that seems like stepping back to the Earth observation. So is there any reason that for the testbed 19 or still have some of those like satellite focused discussion about ARD?
So per pixel, that's a good catch, is a CS term. We would say, per cell or per grid. So each, the smallest element of the data product, we should have metadata about where it came from. And some of that might be, in some cases, which pixel of the original image it came from. My view is that for ARD, the consistent quality is more important than individual quality. But that's a matter of I think opinion and application.
Yeah, thanks. Alexei Shikleman of NASA Goddard. So this is all very good, but I kind of wonder, like, we're going to have these really lovely, thoroughly documented standards, with all these details, but then who's going to actually adopt them, right? I mean, so if you were to guess, what are the next 3 data sets or the next 3 missions that are going to sort of implement the standards that you've outlined here? Or are we just going to have a standard with no actual data sets that follow it?
Well, I mean, we already have a number of data sets which are self-certified as, compliant to CSARD specifications. We don't have an independent certification of that. And for most commercial providers, there's a very indirect self-certification. So there are already products which recognize the value of being analysis ready, which are a ways from an optimal state of analysis readiness. So that's kind of a built-in market, which means on the one hand, we want to increase confidence, and they'll be in favor of that. On the other hand, it can't be too difficult or expensive. So that's an interesting balance.
Okay, thanks. I guess just a quick follow-up to that. So for the data sets that are very clearly not any of this, right? So very clearly not analysis ready. And Dave brought up level 2 data sets, of which we have a bunch, these sort of swath level things from NASA and other organizations. What does the pathway look like to become ARD compliant? I guess it's just our job to sort of read the standard and then implement it. That's basically the...
Well, I mean, it's the same, what's the spatial alignment? In case of many other types of data, what's the resolution? I mean, we can talk about it elsewhere, but, so one of the participants in the disaster pilot wants to look at demographics in terms of working with satellite data. But at the resolution of the satellite data, there's a big privacy concern. So they're setting up synthetic population data in order to do a model, its evacuation priority, which combines satellite information and demographic information.
Well, I think we're running a bit on time. How are we doing? One more.
So I just want to echo Alexi and say that I think there is a risk here that this becomes an academic exercise, and I think we're aware of that. There are telecons on the OGC SWIG right now that are evolving the standard, and we need to get more voices in there, and early implementation, feedback, those sorts of things. And we're looking right now at how we can do this more in the open with actual community participation.
Okay, I think if that's it, we probably should go to the next speaker. Okay, so next up we have Zong Liu from George Mason University, and he's also affiliated with the Data Information Services Center.
So the page is this one. Left and right.
Huh?
Left and right.
Oh, okay.
Yeah. Let me.
Okay, thanks. Good afternoon, everyone. I noticed the coffee was not there, so I still have a jet lag, from a visit to China last week. So, but anyway, hello everyone. Today I'm going to present data quality challenges for analysis-ready data. So this talk is more from a user's perspective. First, I would like to acknowledge my co-authors, Bob, Peng, David, Rama, Yashin, and Changling. And they are also members of the ESIP Information Quality Cluster. Okay, background. First, let me give you some background information on the ESIP Information Quality Cluster. As we all know, data quality plays an important role in research and applications. And the ESIP Information Quality Cluster defines information quality in 4 aspects: science, product, stewardship, and services. So this talk is probably more focused on the services part. So the first 2 are associated with science, and the remaining 2 aspects are data repositories. As you can see, it needs a lot of community effort to identify data quality challenges and solutions. So, however, it has been a challenge to bring all the stakeholders together. For example, we need more scientists to participate. So therefore, we have more work to do. So the ESIP Information Quality Cluster was formed many years ago. And over the years, we have published recommendations and research papers to improve data quality. Our members are active in national and international data quality activities, such as WMO, AGU, RDA, and NASA. You can find our wiki pages here. There's a link there. And we encourage you to be a member of the cluster and participate in our activities, including our monthly teleconference and future ESIP meetings. So in recent years, cloud computing environment basically provide scale-up capabilities such as data archives and services, enabling interdisciplinary science and applications. So more value-added products are expected, including analysis-ready data, ARD. So let's see. So what is analysis ready data? So previous speakers already mentioned a little bit. Yeah, so basically that's very similar. So here is ARD refers to data that has been pre-processed into a form that allows immediate analysis by the end user process to be minimum set of requirements and provides interoperability over time and across multiple data sets. So once a data set has been developed from its original form to produce ARD, so what characteristics would be needed, like preserved or further refined to identify, represent the quality of the ARD. This also applies to ARD with multiple data sets as an input. So not just only one data set, and can be multiple data set, and after the process, it can be like one or multiple, output. So is an ARD consistent with the quality of the source data, or are there any special attributes that warrant a secondary independent quality assessment? Yeah, and do we need to add a capability for open science, such as a tracing back to the pre-processing? Yeah. And it is important to answer these questions, especially given the ease of use of ARD and the consequent temptation by users to trust the ARD without understanding the limitations or possible variations in quality compared to the source data. So why ARD is so important? And with ARD, scientists basically can spend more time on research, as we, previous speaker already mentioned, and less on data processing, such as format, grading, aggregation, the so-called 80-20 rule in data science. So an example is during the TRIN era. TRIN stands for the Tropical Rainfall Measuring Mission. So that was the first US mission. So Geodata developed a value-added daily precipitation product based on the 3-hourly standard product, of the TRIN multi-satellite precipitation analysis. So this daily product is one of the most popular product in the TRIN product family. Yeah. So to meet the fair guiding principle requirements, for example, if a user search for a daily precipitation product, the search result would be empty if the product was not available, for example, yeah. And having its ARD available will facilitate data finding and access, as well as increase the use of a product like a TRIN daily. Let's see. So open science also providing a transparency of processes, workflows, pre-processing workflows. All processing software is open, and workflow can be recorded and reproducible. So enabling interdisciplinary science, for example, different data set can be on the same grid for comparison or for other purpose. So here's a case study. Let's take a look at the satellite-based product. Yeah, here is the Global Precipitation Climatology Project, also known as a GPCP product suite, including a daily and a monthly product. It is a global multi-sensor, multi-satellite product suite. And the monthly product has been used in many research papers, and it's very popular in climatology studies. So the table at the top of the right side shows daily parameters. As you can see, there are only 2, precipitation and liquid phase. Compared to the table below, they show a whole list of parameters, including the random error. As you can see in the daily, that random error is missing. So because data producer didn't know how to generate that kind of product, so additional research is needed. Yeah. So from this case study, we identify several challenges in generate this ARD. So single sensor and multiple sensor products. So for example, the iMerge, the integrated multi-satellite retrievals for GPM, and there are multiple data quality challenges which we don't fully quite understand right now. Yeah, and they're also difficult to generate data quality information, as mentioned earlier, and the satellite sensor conditions and the operations, which are relatively easy to get this, from like a level 2 data products, and lacking in situ observations such as gauge and the ground radars for ground validation, bias correction, algorithm refinement, especially over ocean and in polar regions. So the uncertainty are very big in those regions. So error estimate for the right product like iMerge daily and the 5-day or 10-day precipitation. So we still don't have enough knowledge in this area. That's a huge challenge for on-the-fly, data services. Yeah. And also data quality for AI/ML, that's another challenge too. So nowadays it's easy to generate AI/ML products. So what can we do from here? We need to support data collection in situ and satellite, data integration, standardization, and the fair, and let's see, yeah. And the fair principle on a global scale. So without this integrated, observations, it's very difficult to estimate data quality. Yeah. Also providing global information for open science, like satellite instrument conditions and anomalies. Promote data quality standard and the best practice, as we see in the previous talks. Yeah. Also support data quality research. As we can see, we still have very limited knowledge about, the right product, data quality information. And the data service quality as well, we need to better understand, whether or not the service performed normally or not, So that information very important. So community engagement, like AGU union session, that probably will bring everyone, stakeholders together, not just the informatics session, So in summary, there are many challenges in providing data quality information for analysis-ready data. So community efforts and the collaboration are needed to guide ARD development and the services. Yeah, we need scientists, especially product producers, to get involved. Yeah. So more data quality research activities are needed to better understand and provide the data quality information, in ARD. That's all I have. Thank you very much.
We have time for a quick question for Zon. Questions?
So I think a user probably will expect more and more on the fly services. So we need to have actually the idea is came from many years ago. There's a microwave workshop. We discussed whether or not we need to apply the DOI to on the fly products. Yeah. It's
yeah. Thank you. So next up, we have Pei-Xing Zhao. He's also GMU and also affiliated with the Battery Sciences Data Information Services Center. And he's going to be talking about
hello everyone, I'm Pei-Xing Zhao from NASA JustDisk. Today I'm focused on some technical detail about how to generate GIS analysis ready data using the ArcGIS software for the chop-omit data. So first I will introduce what we have done for the GIS analysis ready data at JustDisk. Then I will use ChopOmi as the example to demonstrate how to generate GIS analysis ready GIS analysis ready data using the ArcGIS. And last, I will talk about the challenge we have got. So there are many data hosted by JustDisk that are highly valuable for the GIS applications in the areas of the extreme weather events, climatic anomaly, and the public health. For instance, we have data sets such as the TRIM and the GPM that provides the measurement for the precipitation. Additionally, we have the LDAS dataset that provides the various land parameters, such as the soil moisture, evaporation, and vegetation index. That are very important for the hydrological modeling and the analysis. We also have the MERO2 data provides the comprehensive information about the land, ocean, and the atmosphere. So we also have the dataset such as the ERS, OMI, and the ChopOmi that provide the valuable information about the atmospheric compositions. Then this data can be used in the monitoring the air quality and its impact on the public health. So, however, there are some challenges for the GIS users using the NASA Earth Science data. Many GIS users are not experts in the Earth observation and have no knowledge about NASA Earth Science data. So, in the GIS community, the most widely used data format is the GLT. But most of NASA data in the complex, the multidimensional 90CDF and HDF format. So this complexity has made it very difficult for the GIS users to use the NASA data. So although GIS software has, like ArcGIS, has made progress in processing the multidimensional 90CDF data, but there are still some issues, particularly with the level 2 data. So in recent years, the NASA JustDisk has made lots of efforts to make the data more GIS analysis ready. For instance, we employed Giovanni to facilitate the data exploration and the transformation into the GIS tools, and published the ArcGIS image service and the related OGC services. So we also developed some step-by-step how to document to guide GIS users to use the NASA data. So the Giovanni offers user-friendly interface that enables the users to access and analyze various types of the Earth science data, including the satellite observation, model outputs, and the ground-based measurements. One of the key advantages using the Giovanni is the ability to transform the data into the GIS-friendly formats, such as the GLT. This capability allows GIS users to directly incorporate the data into their GIS workflows and conduct further spatial analysis. So in recent years, we have collaborated with the E3's ArcGIS image team to make our data available through the ArcGIS image service and the related OGC services. ArcGIS image service provides a powerful means of accessing, visualizing imagery and raster data within the ArcGIS ecosystem. OGC services can be accessed through various client applications, including the web application, desktops GIS software, and other applications that support web services. This picture shows rendering GPM emerged data through the ArcGIS image service in the online map view. This service allows users to view and analyze the GPM image data within the familiar with the ArcGIS environment. So JustDisk also created a detailed instruction document to guide GIS users step by step on how to work with NASA Earth Science data in the GIS tools. So next, I will talk about the CHOP-ARMY data. CHOP-ARMY is the tropospheric monitoring instrument, which is the sole payload on the Sentinel-5 precursor satellite. CHOP-ARMY's spectral range covers ultraviolet, visible, near-infrared, and shortwave infrared wavelengths. It provides data on several trace gases and constituents of our atmosphere, as well as the cloud aerosol properties. CHOP-ARMY is particularly useful for air quality management and is well suited for the monitoring of wildfires and assessing their impacts. So the CHOP-ARMY level 2 data files are organized based on orbits and the days. Each orbit is stored in the separate file. The data format is the NetCDF. For each day, there are about 14 to 15 data files stored in a folder, covering global extents. So the spatial resolution of the data is about 5.5 by 3.5. The temporary coverage of the data ranges from the July 2020 to present. So this is the workflow we use to generate CHOP-ARMY data for the GIS analysis ready, including the create a feature layer and convert the feature layer to the graded raster dataset, and the mosaic the graded raster dataset into a daily raster dataset, and create the symbology and publish the image service. CHOP-ARMY level 2 data consists of irregular pixels, and the geolocation information is very important for the data processing. There are two types of the geolocation information available in the data file: pixel center, latitude, longitude, and pixel corner coordinates. These coordinates define the boundary of each pixels. So with this information, we can create a polygon layer with this information. So we can use the pointer center, latitude, longitude to create the point layer, but this layer is not accurate represent the shape of each pixels. So we choose to use the polygon corner information to create a polygon layer that can be represented exactly the shape of the pixels. So this is the Python code. We used ArcGIS Python library, ArcPy, to do this job. Because the variables dimensions within a group in the NetCDF file are not directly supported by the ArcGIS library, ArcPy. So the convert raster to feature, the function we cannot use it directly to convert the data into a feature layer. In this case, a manual approach is required. In this approach, we need to create the polygon feature class, then add the necessary fields to the polygon feature class to store the variable information associated with each pixels. Then use the NetCDF library to extract the pixel boundary information from the data file. Then use the pixel boundary information to create the polygons for each pixels. Then add each polygon into the polygon feature classes with the associated fields information. Next, we need after we create the polygon layer, we need to convert this polygon layer into the graded raster datasets. In this step, we set up the cell size equals 0.06 that matched to the original data resolution. We also choose the maximum combined area options for the cell assignment. In these options, combines the polygons with the same value within each cell. Then based on the area of the combined polygons and assign the value to that cells. What? Okay, right. Okay. So after we created the graded data set, so as I just mentioned, there are multiple chop-omit level 2 data file available for each data, typically ranging from 14 to 15. So to merge these data files into a single raster data set that covers the global the extent. So we use the Mosaic 2 new raster functions to merge the input rasters into a seamless mosaic. Additionally, we create a new raster data set in the cloud raster format. CRF is a specific format of the E3 ArcGIS software. So the CRF is optimized for the cloud storage and the access. So by using the CRF, we can enhance the performance and the accessibility of the raster dataset in the cloud environment. So we also use the GIPS the color map to create the symbology. With this symbology will help visualize and compare the chop-omit imagery in an intuitive manner and consistent with the other GIPS product. So after data is ready, publish a service becomes an important step in distribute and share of the data. So we use the MDCS developed by E3 to create, config, and populate a mosaic dataset along with the time dimension. So then we use ArcGIS Pro and ArcPy to publish the mosaic dataset in our image services. Okay. Okay, this is the image generated by the OGC WMIs with the GIPS styles. So with the OGC services, users have the flexibility to customize the imagery and the data. So this allows the user to access and view the chop-omit L2 data according to their specific needs. Okay. User can also use the chop-omit level 2 data through the ArcGIS image service in the ArcGIS Pro. Users can leverage the capabilities of the ArcGIS Pro to conduct various raster analysis. Okay. In summary, so by leveraging ArcGIS image services and OGC services, so it allows users to analyze NASA or Sense data directly in user primary GIS tools and the software. By using the how-to document, including the Python code, it enables users to customize GIS customize GIS analysis-ready data. So we also have some challenges when preparing the GIS analysis-ready data. So the first challenge is the choice of a single CRF and the mosaic CRF. The second challenge is the published feature service and the image services. Because the feature service can be directly the polygon data into the user, but the performance is a big issue. When we're dealing with the large volume the polygons. For example, dealing with the 20 million polygons in our data file, in our daily files. So right now we are focused on the improved performance on the how to generate the daily CRF data, because right now we need to take the 7 hours to generate the daily chop-omit data. Okay, that's it. Thank you.
Okay, so I apologize, Pei Shing. You do have to keep this moving. If there's any questions for Pei Shing, I'm sure you'll be available during the poster session.
Yes. Yeah.
And so we're going to be queuing up Lee Ping Z right now. We are going to be running a little bit late. I apologize for that. Eugene gave a little part of this presentation toward the end, so please bear with us. Thank you.
So, Eugene, how should I control? Can everyone hear me?
We can hear you, yeah.
Yeah. So how I can control the slides?
They're coming.
Should I share my screen? So
We got it. We got it on this end.
yeah. Hello.
Yeah, do you want to drive it or you want to ask?
How do I drive it? If I can share my screens and I can drive it.
Yeah, he can allow you share.
We're up.
Okay. Okay. So then someone need help
I'm
me.
buttons. Go ahead. Dive in, Lee. I'm here.
Okay. Yeah. So thank you, everyone. I'm going to talk about standardization for geospatial analysis ready data through ISO and the OGC process. I'm going to report current progress on the development, and I first acknowledge my co-author on this presentation, include my colleague Lin and also Josh and Ingo from OGC. So next slide. So, everyone knows CR's definition of analysis ready data, but, this definition is pretty ambiguous. So what means minimum set of requirement and also minimum additional user efforts and interoperability. So, the definition itself will also subject to the interpolation and standardization. So this is why, we need to standardize the ARD concept and also the terminology. And currently, the ARD is a CRS-wide initiative, and CRS has developed over 10 ARD product family specification. And I know several space agencies has produced products claim comply to ARD specification. For example, USGS has produced Landsat reprocessing products that for the land surface reflection products that is ARD compliant. And in the CRS, currently the CRS ARD oversight group manages the CRS ARD activities, and the calibration validation group performs compliance peer review. So they do have someone to review, and once passed, they put the CRS ARD compliant stamp on the product. The next slide. And so why we need to standardize the ARD? Basically now have a lot of people claim their product comply with the ARD, and really we need to standardize, because CRS itself is not a standardized organization, and currently the ARD definition is only based on the CRS view of what ARD should look like, and CRS and want to broaden the concept and get a consensus from the community on what the ARD should look like. And so, the approach, ISO and OGC, want to go through a formal standardization process. And so, to form a broad community consensus and make data more interoperable and the concept more accessible by the community. Next slide. So with CRS support, OGC disaster pilot 2021 include an action item to develop a recommendation for how to standardize ARD, and we conduct some study and made the following recommendation. First, I use CRS ARD spec as the base. And we want to build on existing OGC and ISO standard, and want to achieve broad community consensus and be a joint ISO and OGC standard development efforts, and go through the formal standardization process and publish both ISO and OGC standard. So next slide. And we also envision that the ARD standard will be a multi-party ISO and OGC standard. And the part one to be a framework and the fundamentals is, put all the common things in this part and also divide, decide how to structure subsequential part of the ARD standard. And so the part two, part three, part four, part five, those are just initial thoughts and the subject to the project team to decide, and the community, entire, geospatial community get, agree, and how we're going to divide ARD into a different part. And one particular thing that I think important is that, first of all, we want to expand this from just from the remote sensing data to more broad geospatial data. So like data from model and also some high-level products that are already processed. And one additional thing is that I think is important that is we should define the service, ARD service. So people really, analysis ready data that through the service, user really can get the data that specifically processed for their specific application. Otherwise, we have a data set put in place. This maybe can, generate and apply some common process. So when user get the data, they can reduce the processing burden, but they really still need a more step to process before they can analysis. But if we have a ARD service that can provide a customized product, the user can really get the data immediately available for analysis. So this, I think, we should have a geospatial ARD service spec also. So next slide.
So Li Ping, real quickly, we're kind of at time right now, so I'd really appreciate it if you can move forward, and I apologize for that. So thank you.
What? You?
Yep. Okay. Go ahead, please.
Okay.
Can you see the slide?
Yeah, slide, the next slide. Hello?
I'm here. Next slide after this one?
You go back, okay. So we're going to set up the ISO TC211 ARD project and OGC ARD standard working group. So two teams can work together to develop the both joint ISO OGC standard. So we envision that both teams going to have a large overlap among the membership between the two teams. And for the OGC ARD standard working group, we need be set up through the standard working group charter approval processing. And for the ISO, we need set up ISO standard project through the new algorithm proposal process. Next slide. So the OGC ARD standard working group, we drafted a charter in May 2022, and has been extensively reviewed by CEOs, ARD, oversight working group, and OGC members. And charter was finalized in November 2022 and finally approved by OGC on May 3rd, 2023. And so we had first in-person ARD standard working group at 126 OGC member meeting in Huntsville last month, and we discussed the work plan and also the outline of ARD standard part 1. And we also have currently, we have a joint ISO OGC bi-weekly telecoms that start from June 27. Next slide. So this is the initial ARD suite chart member. We have 24 chart member from all over the world. Those are all OGC members, and you know, we as initial charter member. So next slide. And as Josh has mentioned, you know, they in the OGC, they also have a multiple ARD related activities. Those activities include activity in climate resilience pilot, in the OGC disaster pilot, and also testbed 19 pilot and 19 testbed 19. All those activities will support the suite, the ARD suite. Next slide. So the ISO ARD standard project, we submit a new work item proposal in December 2022, and the new work item proposal was reviewed and voted by all the ISO TC211 34 countries, and also over 20 liaison organizations. And then the new work item proposal was approved on May 22nd, 2023. So we had an ad hoc project team meeting held in on May 15, 2023, because the project new work item proposal was not officially approved on May 15th. So we only had an ad hoc meeting in conjunction with 56 ISO TC211 plenary in South Korea. Next slide. So this is ISO 19167 Part 1 project team, and we have 9 country nominate experts to the project team, as well as 3 liaison organization, OGC, IEEE, and the CIOS nominate experts to the project. And you can see that we have a large overlap between the ISO 19163 Part 1 project team and the SWIG. Next slide. So, for the current task, both ISO project team and the OGC SWIG is to develop ISO 19176 Part 1. The title for the standard is Analysis Ready Data Part 1 Framework and the Fundamentals. And so in the future, all the ISO ARD standard will be ISO 19176, but will be Part 2, Part 3, Part 4, Part 5. And so ISO designated that all the ARD will be 19176. And the Part 1, we want to define the overall structure, terminology, common structure, all those. So, and this is the 2-year development period, start from the May 22nd. So we expect that if everything goes smoothly, the Part 1 will be published as both as ISO and the OGC standard in May 2025. And if the development have a problem, we need extension, we can get a 1-year extension maximum. So we ideally, we will develop a standard within 2 years. If not, the maximum will be 3 years. So next slide.
So Li Ping, can we get to the conclusion here? We're kind of losing.
Yeah. This is going to be last one. So, so we, hope purpose of ARD standard process is to form consensus on the ARD from the community, and so this we want to maximize the interoperability among diverse geospatial data and broadening the community acceptance and adoption of the standard. So we invite experts from GIS remote sensing community to participate in the standard development, and you have multiple ways to involve in the standard through the CS, IEEE, OGC, or your national mirror committee for ISO TC211. So if you want to involve in the standard development, contact me and I can put you into either ISO project or OGC project, depend on your organization's status, is a OGC member or CS member or not of the member, okay? But we have a different way to put you into the project to develop the standards. So that's it. Any questions?
Yeah, thank you. I don't think we have time for questions like him, but thank you.
Okay.
Okay, so I would like to give Eugene here just a chance to get up and at least talk very quickly about what he was going to say in his presentation. So I really appreciate that. And at the end of it, I want to make sure everybody's tested on that they memorize the COS definition. Just in case you missed it. So I appreciate you guys hanging in here.
I don't think I have time to cover everything, but I just want to emphasize on this talk. I actually have two co-authors and leading scientists and experts on this matter. It's a training data set. We actually published one paper on this for the cropland, irrigated cropland training data set last year. And this one is basically we just passed one of those newer standards on the training data markup language for artificial intelligence. But I think it's the initial idea is basically targeting 3 applications, basically for scene neighboring and object recognition, and also pixel level, the classification or whatever, change detection or those things. And basically we developed how you're going to pass those training data to the users in a standard way. You can do a benchmarking or whatever that it is, so they can reuse it. And so I think just show one slide, probably that's, I'm going to stop here. Then, go check out the slides, and there's a link for tools for you to use the standards. And also they have because basically the idea is quite similar for you to do the CS and ready data. They target as provide the metadata at the data set or collection level, and also down to the granular level or the element level. Basically, we're provided the metadata and also pass through the actual data. So they also have the extension to work with the stack, which is probably that one of those catalog system. They have the extension, and check it out. I think I'll stop here. Thank you.
So I do really apologize that you kind of got crowded out. Sorry for that. I really want to give a quick round of applause for everybody who contributed to this, and thank you guys for attending.